Okay, let's do one more one question about the reduction of order method. So this is the question which I have taken. One of the solution of this equation is this, and then find the second solution by the reduction of order method. So let me rewrite this equation. So this is the equation. So this equation has been written like this. Okay. Yeah, I made some mistake over here. Is equal to this. So in this form, I have written this equation. So let's say we call this y1 as a function of x. Like this. So if we want to define y1 as a function of x, so we can define it in this manner: x underscore bracket close, and then there should be a colon, and then we will enter it. So in this way we will define y1 as a function of x. Then let's define a function as u. Okay, so now I have defined a function u. Now let's take function y2 as this, because for the reduction of order the function y2 will be equal to the u times y1. Okay, and we know that y1 is equal to 1 plus x, so we replace the value of we replace the function y1 with 1 plus x. Okay, so in this way we will get this kind of output over here, which is a little bit strange. Maybe it's because I am getting some initial values. So let's initialize some of those values. So y1 is clear. Let's clear the contents of y1. Okay, and let's try. Okay, and then still I'm getting like something like c1 into x plus 2 over 1 plus x. In order to remove this error, maybe I can try to initialize the value of y2 as well. Still there is some problem. It seems that some problem is happening because maybe u has already some value. So let's clear the value of u. Okay, like this. And now I can try to run this function. Yeah, now it's correct. So now y2 is equal to 1 plus x is u times x as we want it. Okay, so next we need to calculate for the reduction of order method. We need to input the values of y double prime and y prime. So let's say the first derivative of y2 is y2 d1. Yeah, so first derivative, let's say first derivative of y2 is y2 d1. So its derivative we can find by this d function. So it will be this. And let's take second derivative of y2 is y2 d2. So we can take the second derivative of y2 by taking the first derivative of y2 d1. So here you can see that y2 d2 is equal to the first derivative of y2 d1. So we execute it, and now I get this. So it will be 2u prime x plus 1 plus x u double prime of x. So now I have the values of the second derivative of y, first derivative of y2 and y2. So I can input these values into the equation, okay, to reduce the order. So the complete command will be like this. So here what I have done over here is I have just written down the equation, okay, original equation, and now I am replacing y double prime with y2 t2, y prime with y2 t1, y with y2, okay, and then also at the same time I am applying the simplify function. So after doing this command, so I will get this equation. So this is an equation in which I have got u double prime and 4u prime. Here I can take one more simplification. That simplification is that I can replace u prime with w and u double prime with w prime, okay, as some variables, okay, so that we can convert this second order equation into a first order equation. So what I have done over here is that I have taken this equation over here and then replaced u prime with w and u double prime with w prime. So in this way this equation will become like this. So here I think I am getting some error, so maybe I can try to just for example u prime is equal to, I want to clear it, okay, so it's okay. U prime equal to dot, and it says failed, and then u double prime equal to I think the error from here is coming because of some w. So I can say that w is equal to, I clear the value of w, and similarly I clear the value of w prime. Maybe it's not needed, let's do it. So now we get this value. So for wx minus this, and then so now I have this first order equation. Okay, so this is the first order equation. So in this case we know that the integrating factor, we just say it as mu. Let's initialize it, okay. Mu will be equal to this, this is, since this is dy over dx, and then this whole term will be divided by this, so it will be exponent integrate, exponent and integrate what will be the function? It will be 4 divided by this value, so control V, okay. So it is this 4 from here and divided by this value, okay, and it has to be negative because this term will come on the other side, so it will be negative. So equal to x, and then close the bracket, second bracket, and then I can use the simplify as well over here. here, so I will get this. Okay, so in this way then I will get this value. So when we apply this integrating factor, so on the other side of this equation there is a 0, so and then mu times w prime will be integrated, so in the left hand side it will be mu times w, and when it will be integrated on the right hand side there will be a constant value. So it means that the value of w can be written as like this. The value of w can be written like this. Okay, here. So C1 is the constant which I have taken, and then the value of w can be written like this. So it is something like this. And from the w we can find the u by the integration of this w with respect to x. Okay, so this will be the u, and from u we can find y2, because y2 is equal to y1 times u. Okay, y1 times u, and then simplify, and then I will get this value. Here I am also getting some mistake over here. So y2 is equal to y1 times u. Okay, because mistake is because y1 should go, so maybe we can check the value of y1. Y1 is yeah, I think it's no value is coming, so we have to see. Yeah, so here because the y1 was coming in the answer, it means that the value of y1 actually we by mistake removed from here, cleared it, so we can reassign the value of y1 over here. Y1 was equal to 1 plus x, which was one of the given solution. Okay, so now this will simplify it. Okay, so this is the answer. So this we can just ignore the constant. The second function will be x square plus x plus 2. Okay, so this is one method for doing this by the reduction of order. Another reduction of order method uses the reduction of order formula. So that I will explain into the next video clip.